And if you're taking notes and you're actually engaging in what I'm talking about right now, you guys learned a lot. And continue to sit back and write down and have these things. All right, so we got the answer. It's right in the book. You have to go back a couple of pages, but it's there, right? Now let's go back to the next question. Without doing any research or calculations, we want you to estimate the value of R. Now, this right here is one of those really funny things that lets me, I get a little bit frustrated when I see that people don't even try the homework, right? Because this is not something that's mathematics. This is just an attempt. You could have submitted the homework and the only thing you put it in as a correct answer was 1B. And you would have got 1 out of the point that's needed, right? We're just asking you to estimate. If you sit back and think about what the correlation would be like, and there is no real wrong answer, right? The correlation between body temperature and head circumference. Without doing any research, estimate the value of R. Now, I want you to ask you guys a couple of questions. Do you think this would be a positive correlation, or do you think it would be a negative correlation? All right, now I muted some of you because I was hearing some background noise, but let's hear it. You think it would be positive or negative?
Negative.
All right, so you think it would be negative, right? Now, do you think it would be strong, or do you think it'd be a weak correlation?
Weak.
All right, now weak or start at a low number, so it will be something around like negative 1 point, either negative 0 or like negative up to like negative 0.3 or 0.4. All you got to do is pick a guess, right? That answer is done appropriately. All right, now let's move on to the next question, right? Does R change if body temperatures are converted to Fahrenheit? Now, this is another example that goes back to previous readings. And this right here is something that we have been using and we keep going back to frequently throughout everything that we're doing. All right, so let me go back to this book. This is the page that I'm using that's allowing me to search through information while I'm doing my homework. Another tab open. There's a part right here. Here it is at the very bottom. It talks about the properties. All right, let me get rid of my picture. It's like in my way and I can't see anything. Yeah, you guys can see how annoying this is. We talk about the properties. Now, again, we're supposed to read. That's what the reading assignment quizzes are all about, right? These properties are talking about stuff that you've actually already went over and hopefully took a little bit of note from. The value of R is always between -1 and 1. We know that. If the values of either variable are converted to a different scale, right? Again, we have to read far. The value of R does not change. If all values of either, that is exactly the question that is being asked of this right here for C. And again, it's really one of those aspects of, did you read and take notes on what it is that we're trying to go over for this unit right now? So again, I mean, it's just right there, it's straightforward. But again, it's not straightforward if you're reading and you don't comprehend it, or if you're reading and you don't take notes. And that's what we have to be a little bit more engaged in. Again, this course is unique and it's different in the fact that what we talk about in one chapter builds on the other. And I think the habits that we have of not taking notes and not taking content seriously and reading sentences, not understanding them and thinking that it won't come back later and hurt us, it's really hurting us in this course. I mean, it's handing our work with everything that we're doing. All right, so I got a question out here. Yes, the question is, can I resubmit what we're doing for 10.1? Absolutely. Absolutely. Again, there's a folder in D2L that's been there for the entire semester. I believe the syllabus also speaks of this. Learning from your mistakes is a factor that I incorporate into this class, which to me really is frustrating when I see that people aren't even trying or submitting. They're getting feedback from their work and they're not really doing it. You won't find too many courses that are taught at this institution where the instructor is being like, oh, you tried it, you didn't do it, resubmit it, learn, show me that you've mastered the skill. And the fact that we're not even taking advantage of that, even when we have it in the course, is a little frustrating. But again, I think it might be me. I am sitting back there and letting you guys get away with stuff that probably is not beneficial. And it's promoting kind of just, I'm here, I'm supposed to pass just because I'm alive attitude or something. Okay, now, Next item that we're doing is number 2. It's the next item on the homework. So let's go back to this. Okay. Habit 2 is in my way so much. Interpreting R. For the same 2 variables described in exercise 1, what is that, like temperature and like waist circumference or head circumference? If we find that R equals 0, does that indicate that there is no association between those 2 variables?
Yes.
Yes, it does. Because if we were to have a strong positive correlation, somebody else, what variable would we have, or what would it be close to if we had a strong positive association?
Would it be 1?
Yep. The only thing I don't like about that, Siani, again, you're so confident. You're so, yeah, just speak. Don't do Jeopardy. We're not playing Jeopardy. It is 1. That's what I want to hear coming from. Right now, what if we had a very strong negative association, somebody else, and don't play Jeopardy? What would that variable be or be close to if we had a strong negative association?
-1.
-1. All right. Right. But again, if it's equals to 0, right? And this is saying it's equal to 0. That's like perfectly chaos. There's nothing in there. Absolutely nothing. Okay. So again, you guys know these things. Like I said, so it's really surprising me when I see a very small percentage of us handing in work. All right. Number 3, global warming. If we find that there is a linear correlation between the concentration of carbon dioxide in our atmosphere and the global mean temperature, does that indicate that changes in CO2 cause changes in the global mean temperature? Why or why not? Now, you know what? I'm going to help y'all. I think y'all know this, but this is an issue that happens when we're doing it. You know, we can be in our intro to psych class and we can repeat these things left and right. But when it comes down to applying this to a real problem, we don't necessarily always see it, right? So again, how many people have heard of the phrase correlation does not mean causation? Raise actually, all right. I want you guys to raise the hand raising factor, right? In your I'm going to look at the participants thing. So raise your hand, right? Everybody here, not everybody yet. Jasmine's driving, so I can't imagine. I don't want her to die. Okay, right? So that's almost 100% if I'm excusing Jasmine from what she's doing, right? But yet, I promise you, problem number 3, because we're kind of reluctant to really engage in what we're doing and really apply it, this is really a perfect example of we know a fact, but we can't apply that fact. Look at this right here. If we find that there's a linear correlation between concentration of carbon dioxide in our atmosphere and the global mean temperature, right? So we found a linear correlation. Does that indicate that changes in CO2 cause changes in the other? Now, if you look closely with what I've highlighted, right, focus and engaging, this is that same question. Does a linear correlation between these 2 things imply causation? We know that answer, but yet, like I said, it's very different. That's why we really got to dive in. I've been saying this from day 1 about how this course, it's less about putting in numbers and it's more about statistical and quantitative reasoning. This is a perfect example of something that I know everybody in this room can cite off the top of their head, but yet number 3 might be a problem and you might not be able to see it. But this is the basics. This is the basics. And since, you know, I try to promote, I do this a lot in my class, I try to promote these aspects to make sure that you can not just cite a definition, but kind of apply it in real statistical situations. That's why my classes are perceived by many as being so hard. I felt like I got in trouble the other day. Somebody in this class, or maybe experimental, is angry about what's going on. And of course, the faculty member defaulted to their girlfriend or whatever, thinking that, you know, something must be wrong with me. And I'm just like, no, it really is from engaging in the content. There's a superficial understanding of correlation equals causation, right? And then there's really understanding and how to find it, to make sense out of it, and to apply it to a real world setting. And that's what number 3 is doing, asking you to apply it to a real world setting. You can only do that with reasoning, critical thinking, and really engulfing yourself in the content. All right, I'm going to stop this, scroll up a little bit for number 4. All right, now this says match these values of R with the 5 scatter plots shown below. I can't do all 5 on the screen at once. Now I can. All right. Actually, I still can't with that number. 175. Now I should be able to. Scroll this up a little bit. Now, I told y'all know this, right? Y'all know these values. The values that we're looking at, they're a little small. I'm sorry, but I'll put it in text over here in text. I don't think this thing can get any more frustrating. The values that we have in question are 0.268, 0.992, -1, 0.746, and then a value of 1. What we want to do is we want to match these values with what we know about a correlation with these values. All right, now there's 5 numbers, 5 graphs. I would love to get 5 different people picking them. And those of you who are, reluctant to participate, I suggest you pay attention now because it's only going to get harder. I think the -1 and the +1, those are the easiest ones to jump into. So if you're a little scared, you might want to sit back and make sure you do at the very beginning and get one of those and leave the harder ones for other people. All right, so 5 volunteers, 5 charts, which ones are which? Once again, I think people on the other side of this talk to a muted microphone.
Is E1?
Is E1. All right. So is E1, and look at this. This looks perfect to me. So E is 1. I'm going to go with that. Good job.
A will be -1.
All right. You said A would be -1. That looks perfect to me. Told y'all people. And these are the people who are dedicated, right? They taking the easy ones from y'all. Y'all need to be mad at Amber and Siani a little bit. All right. Now let's go with the hard ones.
Would D be 9? Well, 0.992.
Oh, now you know what? You know what she did? She started playing Jeopardy. Got to repeat that. Say it differently. Say it with your chest. I'm really waiting for you to say it with your chest.
Oh, I thought you was playing. D is 0.992.
All right, now it's getting a little bit harder. All right, guys.
B is 0.746.
All right, B is the 0.746. And again, I guess we say this the hardest. Actually, it's the easiest since it's left.
Yeah,
C
you got it. You got it.
Is it this one? Is it this one? That one?
It's
All right. So we got it right there. Again, this is a situation. This is what these math is really trying to do. Like, we know these numbers. You guys cited off before what the values range from. It's just engulfing. You have to kind of be in this. You have to want to be in this. You guys have to accept that, oh my gosh, in order to be a psychology major, I have to take stats. Spring 2021 is when I'm in stats. This isn't hard, but you have to put yourself in it, right? And I don't think that I'm going to sit back and I guess I'm coming at some people. Some of us are not getting in it. We're just sitting back here and just saying, I don't know, I don't want it, and kind of hoping it's going to go away. Unfortunately, it gets worse. It gets worse. So next one we do are 5, 6, and 7. See something in the chat. Let me comment on that. Yeah, I did. I think I'm recording. All right, so what's going on right here? All right, item 5. And this is one of those that I'm telling you guys, you got to get rid of some of this information that's kind of annoying. And I'm going to do that to begin with as we read it, right? So what are we doing for number 5? First, you got to read this heading. And this is the first part I believe that is many people are missing when I say you really got to get into what we're doing, right? Many people try to go on and answer 5, 6, 7, or 8 without reading this heading. The whole section is kind of defined as interpreting R. Okay. In exercises 5 through 8, use a significance level of alpha equal 0.05 and refer to the accompanying displays, right? So we have to remember that. It might not say alpha equals 0.05 for 5, 6, 7, 8 again. It doesn't need to because it assumed that you guys read this, right? And then you want to refer to the accompanying displays, right? Now that's the global thing that we're doing. But then now we got to read, but even when we read, we can't forget what I just mentioned right up here. Okay, bear weight and chest size. What? 54 wild bears were anesthetized. That means they were killed and actually no, anesthesia, they might still be alive. They just were unconscious for a while. And then their weights and chest sizes were measured. That is not me, I'm sorry, right? Were measured and listed in a table. Now, talk about getting rid of information. This is just the kind of information that confuses you. This whole in data set, blah, blah, blah. I told you, this guy is always bragging about he's using real data, right? We're more measured. So let's get rid of that. That's just a distraction. Results are shown in the accompanying stat display. That's this right here, right? Is there sufficient evidence to support the claim that there is a linear correlation between the weights of bears and their chest sizes? When measuring an anesthetized bear, now these estimates are getting real deep into it, and this is beyond quantitative reasoning, right? And we can do them, but I'm not really going to focus on that right there. That's really your opinion, and those who shared that, I can't really determine or evaluate your opinion. So let me make this a little bit bigger. All right, so get rid of this stuff. Now, the only thing that we really have to pay attention to right now is this. We have to remember that alpha is set at 0.05. That was done beforehand. That was said beforehand. Significance level alpha is 0.05, right? Now, looking at this information, what do we see? The value of R is 0.963. That's cool. Now, the critical value of R, that is the value that we need to find out whether or not it's significant or not. That value is, let's put 0 right here in the middle. 1 is all the way here at the top. -1 would be here, right? Our correlation coefficient is, let's do this number, 0.96. That's probably right there. Our critical, which is like what we need this value to be more than, is way down here, like at 0.267. A little bit past 1/4. So we got to answer the question, is our obtained R more extreme than our T critical? The answer to that is yes. This value is in that T critical region, right? Now that's one way of interpreting it, right? The other way of interpreting it, which is consistent with what our textbook is saying. It's saying our alpha is set at 0.05, right? Now we can look at our p-value. Our p-value is what? All right, that's a real question. What's our p-value?
0.
0, right? So is our p-value less than our alpha?
Yes.
Yes.
All right. So the answer to the question, is there sufficient evidence to support the claim that there's a linear correlation between the weights of bears and their chest sizes? The answer is yes. And it's because we look at the p-value. It's less than our significance level. There's a significant correlation. Now I showed you another technique over here, right? Which is showing you how the same thing about the critical value, if you get a value more extreme than the critical, you get the same exact result. But that's what we just did over here, comparing this 0.0000 to the 0.05. That's all we asked for. That's all we asked for. All right, I'm going to do one more of these. The 6 and 7 are pretty much the same thing. All right. Casino size. The New York Times published the sizes, square feet, and revenues of 7 different casinos in Atlantic City. Is there sufficient evidence to support the claim that there is a linear correlation between size and revenue? Do the results suggest that a casino can increase its revenue by expanding its size? All right, now I'm going to go with this last question because I want you to sit back and understand this is what I mentioned before. This is that application. Do the results suggest that a casino can increase its revenue by expanding its size? Now, isn't that implying causation? It really is. It's implying causation. And if I have a bigger place, then it's going to cause me to make more money. Again, same thing. We know that causation is not equal correlation or vice versa, right? But it's difficult sometimes for us to see it right here. It's difficult. So it might suggest that you might use some soft language, right? But again, you can't really go with correlation. Trust me. I went to a restaurant just the other day. Me and my kids were going, my son's birthday party was go-karting. And the place was horrible. It was huge, right? But customer service and the atmosphere and cleanliness of it, it leads you to sit back. Look, I don't care how big this place is. People are not going to come, right? You got to sit back and clean the place. And yet you sit back and wonder why Chick-fil-A got people lined out the sides of their building. Is it because of their food, because of their space, or is it because they have their cashier to say, look, we will fire your ASS if you do not greet every customer politely, give them follow-ups, talk to them, smile. If you want to walk on with that chip on your shoulder, don't work here. It's more than that. Okay, so what do we look at? We still got to remember, again, we got to get engrossed in what we're doing. Alpha is not on this page, and if you only went right here, we set alpha at 0.05, right? The correlation between size and revenue is this. Ooh, uh-oh. Now we got to think critically because alpha is not given to us, but R is. R is given to us as a value of 0.444. Yeah, just leave it at 0.444. Don't round up. Actually, I probably couldn't. I'll make this 445 if we round up. Is there sufficient evidence to support the claim there's a linear correlation? Now, what information do we need from this? 7 casinos, right? Think critically. N equals what then?
7.
N equals 7. Okay, now we need to peruse through our textbook. Now, if we remember reading through the textbook, it gave us a nice little chart. Actually, I checked. A chart is probably in the appendix. Let's go. Here we go. This chart right here shows us, kind of like I said before, how we can find out the critical values that's needed for a correlation. All right, so for us, N equals, let me clear this, get out of my way. N equals what?
7.
N equals 7. Alpha equals what?
.05.
Okay. These two things intersect where? They intersect right here. Now, I kind of wrote over it, but I'm going to write it again. That value, the critical value is 754.754. Right? Now I'm going to get rid of this. We found this. Let's go over to here. Our correlation is 0.445, right? Now, we did this before already. And this is the reason why I showed you two different techniques to do this. We got our number line, zeros in the middle, one's over here on the extreme. What value did we actually get from this? We did our analysis. Our value of R equals what? I promise you it's on this page. I know you guys are talking to a muted mic.
It's the 0.445.
You know what? The only thing she did wrong is, again, she did it again, playing Jeopardy. All right, let's say 0.445 is right here. We're going to estimate that, right? Now, we just went in the back of the book. We just found the value of the critical, right? That's what it needs to be more extreme of. What was our value of the critical?
754.
Yeah, 754. So let's make that half. 7.5 is a little bit more than 3/4. Right there. All right, let's draw a line. That's our critical line. All right, let's sit back and do the shading part of it, right? So we can see what it looks like. In order for us to say that we have a significant correlation, what we obtain must be in the extreme region. I don't think when you do all these steps like this, I don't think it's even a question. Is our obtained R more extreme? Does it suggest that we have a linear correlation? Don't be scared.
Can you repeat the question?
All right, based on what we have right here, the R that we obtained, does it suggest that we have a linear correlation?
No.
All right, now tell me why. Why do you say that?
I'm like looking at the line because like when it was the little like the marker was in the shading.
Yep. I think you're saying it right. I'm letting you struggle through it a little bit, but that's what we need to do. This value right here is not in that shaded critical region, right? Since it's not in that region, it's not as extreme. If the value was over there, we would say that it is significant. But since it's not, we're going to say that there is no evidence. So is there sufficient evidence to support the claim? No. And do the results suggest that the casino can increase its revenue by expanding its size? We couldn't do that anyway because correlation doesn't mean causation. But you don't even got a strong correlation to sit on. You don't even have a good, strong correlation. So you really don't need to sit back and talk like that. And that goes from this process right here. This is in my mind, it's the critical reasoning. It's in getting engulfed in the content. It's going over it. This is what's needed to really make sure that we can grasp this. 7 and 8 are identical to this process. I'm not going to go over those. Let me see. The next thing for the homework, which we're not going to get to, is doing 13 and then 17. And again, what I actually saw with the homework, and you guys will probably see it on your feedback, people were trying to do this homework without creating this table, right? And when you're not creating a table and I'm looking at your math, and it just seems to me like you're getting the answers from somewhere as opposed to doing it. But again, the best way to do this is to take those values. These values will be listed in a table like this. It's what they look like in the textbook. But in order to do this by hand, which is what we're doing, you have to create a table. And when we put these values into here, we put these values into there, Then we can go across and we can calculate x squared by hand. That's manageable. Y squared by hand. That's manageable. That's 5.5 squared. That's this number right here. And then we'll do x, y. And that's 79.5 times the 5.5. And we'll fill in these. The next thing that's needed is for us to, by hand, if we're doing this the right way, to sit back and calculate the sums of these. So we do sums of all these titles. Sums of all these columns, I mean. And then once we do that, first of all, we're halfway get to what we need to do. Then we can use this equation. Then this equation makes sense because we can plug the appropriate numbers from this into that equation. But again, we need to see this table. This is how I let me know you guys don't have access to SPSS unless I'm not aware of something. You guys don't have access to other software. So just magically getting the answers is, my mind is suspect. This is the approach that we're doing. And it really takes getting engulfed in the course and able to be able to do that. All right, everybody, that is my review of the homework for 10.1. I hope that this can help you guys get you there. I'm going to stop recording right now.